In this program, we will look at two kinds of power transmission drives, those using roller chain and those using silent chain. We'll see how they are constructed, how they work, and we'll look at some of the most common reasons why they fail. Both roller chain and silent chain are positive drives. Unlike flat belts and V-belts, which lose some of their power through slippage, these positive drives mesh with their sprockets and transfer nearly all of their power from the driver unit, often a motor, to the driven unit, the machine being operated. Typically, they are used in low-speed applications where high torque or rotary force is necessary. They also perform other important functions. For example, they may increase or reduce the speed of the driven unit by using sprockets of various sizes. They also allow the driver motor to be positioned away from the driven unit. And they allow one motor to provide power to several driven units at the same time. Let's begin by taking a closer look at roller chain. Roller chain is actually made up of a series of roller links connected by pin links. The figure-8 shape of the chain's links, by the way, reduces the weight of the chain without reducing its strength. Let's look at the roller link first. It has two side plates, two bushings, and two rollers. The rollers slip over the bushings, and the bushings are press-fitted into the two side plates. This keeps the rollers in place and still allows them to spin freely around the bushings. The pin link is used to connect one roller link to the next. It has two side plates and two pins. The pins pass through the bushings of two adjacent roller links. The roller is the key element of a roller chain, since it's the part that comes in contact with the sprocket teeth. Chain wear is minimized because the roller spins to a new position after each contact with a sprocket tooth. Roller chain is sized by its pitch, that is, the distance between the centers of the adjacent pins in a pin link. When chain must be shortened or lengthened by just one pitch, an offset link is used. The offset link is a combination of a pin link and a roller link. The pin at one end of the link is passed through the bushing of the last roller link on one end of the chain, and the pin at the other end of the chain is passed through the roller bushing on the offset link. Because an offset link is weaker than a normal pin link, it should be used only if absolutely necessary. Chain usually comes boxed in pre-packaged lengths. Often, however, it's necessary to join the ends. The special pin links to do this will have a side plate that slides on easily, sometimes called a coupler link, or one that presses on with some interference, sometimes called a connector link. The interference fit of a connector link is preferred, since the tight fit reduces friction and extends the life of the chain, especially during severe duty. The side plates of smaller chain are normally held in place with a spring clip, while larger sizes use cotter pins. For regular chain to be able to flex properly as it moves, some clearance must exist between each joint. The effect of this clearance is that the length of the chain can vary. You can see the variation in length by laying a length of chain on the floor, holding one end, and pushing and pulling on it. Because the length can vary, chain tends to climb out of its sprocket when operated at high speed or under low tension. When roller chain fails, it may be one of several kinds of metal fatigue, but the most frequent cause of breakdown in chain is the lack of lubrication. In general, roller chain should be lubricated as much as possible. To provide maximum protection, the oil must flow freely into the joints of the chain during operation. Different oils may have to be used on different chains if they operate at different temperatures. For example, an application at normal room temperatures may require a standard SAE 30 weight oil, while an SAE 50 weight oil may be required near an oven, or an SAE 10 weight oil may be needed if operating temperatures plunge to 0 degrees. The most common method for oiling open chain is drip lubrication or an occasional squirt from a hand oil can. Be sure to oil the upper edges of the link plates so oil can coat the pin, the bushing, and the roller. To get the full design life out of the chain requires an oil covering, like an oil bath, through which the chain moves. At very high speeds, a pressure system should be used to spray the oil directly onto the chain during operation. Chain that is inadequately lubricated will often develop a rusty-looking discoloration. Roller chain may also fail from metal fatigue. One kind of fatigue occurs on the side plates. A crack forms, then gradually lengthens until it splits the plate. This type of failure normally occurs when a chain is continually overloaded. Another kind of fatigue occurs on the rollers. Small hairline cracks develop on the outside of the roller, then gradually eat their way through. At this point, the roller can actually fall off. This failure usually occurs when roller chain is operated at high speeds, which constantly hammers the roller on the sprocket. A third kind of fatigue is called crystallization embrittlement. This is a molecular disturbance of the metal in the chain when it is operated in relatively high stress, corrosive conditions, or when it comes too near to plating solutions. The metal cracks as it ruptures from the inside. Any sign of metal fatigue indicates the chain should be replaced. Generally, that means replacing the entire chain, not just individual segments. That's because in most applications, roller chain wears evenly throughout its length. Replacing a few worn or cracked sections will not generally increase the life of the chain as a whole. When inspecting chain for wear, or when replacing chain that is broken or is worn, be sure to inspect the sprockets for debris in the teeth, for wear and for damage. Installing a new chain on a worn or dirty sprocket, or running a worn chain on a new sprocket, will cause rapid wear of the new chain or the new sprocket. Sprockets that need to be replaced will be clearly worn when compared to a new sprocket. Worn sprockets may be sharpened to an almost knife-like edge. Their teeth may be misshapen, or the chain may bind and run roughly over the sprocket. There are several types of sprockets and hubs. The A, or plate sprocket, has no hubs, while the B sprocket has a hub on one side, and the C sprocket has hubs on both sides. The fourth type, the D sprocket, has detachable teeth, which are bolted on and used in applications where teeth may have to be replaced, but the hub cannot be removed. Sprockets normally come with hubs bored to standard sizes, so larger shafts may require sockets bored to fit them, sometimes with a keyway added. Some sprockets' hubs have adjustable bores. The most common are the QD, or quick disconnect, and the taper lock. These units are tapered to fit inside the sprocket, and a gap acts like a spring. Tightening the bolts clamps the hub tight to the shaft. Now let's take a look at the other kind of chain drive, silent chain. This type of chain is often called timing chain. Because of its unique shape and design, this type of chain operates much more quietly than other kinds of chain. When the individual links in the chain make contact with the teeth in the sprocket, it's like two gears meshing. One familiar application for this type of chain is in automobile engines. This kind of timing chain is used in most automobiles manufactured throughout the world. The main area of wear on this chain is in the pin, and most manufacturing variations are in the way the links are pinned together. In the past, timing chains and their sprockets were not interchangeable because different manufacturers use different pitch lengths as well as different sprocket tooth designs. However, most silent chain made today is prefixed by the letters SC. As long as the pitch lengths match, the different chains will be interchangeable from one manufacturer to another. However, since the pins may still differ from manufacturer to manufacturer, connecting links and sections of chain are not usually interchangeable. Normally, unless adequate stocks of a particular manufacturer's connecting links are kept on hand, the entire chain will have to be replaced if chains must be made shorter or longer. Timing chain also includes guides in the chain and on the sprocket. This chain, for example, is known as center guide chain. A solid link protrudes from the middle of the chain, and a matching groove is cut down the center of the sprocket. The center guide holds it on the sprocket and stops it from running off. This is used more frequently on wide chain. Some silent chain has side guides with protruding sidebars that keep the chain on the sprocket. Sprockets for silent chain are not interchangeable with roller chain sprockets. The size and shape of the teeth on a silent chain sprocket are designed to mesh with the links of silent chain and will not work with roller chain. Finally, remember that no matter what type of chain drive you have, it must be installed correctly and it must be maintained properly. When replacing chain or sprockets, be sure you align the sprockets. Misaligned sprockets will usually wear out the inside surfaces of the links and the flange faces of the sprockets. When tensioning any chain, always follow the manufacturer's recommendations. As a general rule, chain should flex about 1 inch for every 20 inches of span on a horizontal drive, half that for a vertical drive. Very often, chain drives with long spans have idler adjustments to correct for long spans. New installations should be inspected after the first 100 hours of service, then every 500 hours after that. Chains running under severe loads should be inspected after every 200 hours of operation. Remember that selecting a chain drive is generally done only once, but to keep it operating correctly and efficiently requires consistent maintenance.